All right, this video is about central and inscribed angles in a circle. So the first one is a central angle, which you see a picture of there, and the rule governing arcs and angles involved in a central angle is very simple. The number of degrees in the arc equals the number of degrees in the angle that the arc that the angle intercepts. So for example, here you see a 90-degree angle with its vertex at the center of that circle. You can see that this arc here comprises 1/4 of the circle. And of course, 1/4 of 360 degrees, which is the amount of arc in the entire circle, is also 90 degrees. So very simple right there. 90-degree central angle yields a 90-degree arc. The inscribed angle is not quite as simple, but still not too bad. Here, the angle measure times 2 is going to be equal to the arc measure, or put another way, the arc measure divided by 2 equals the angle measure. So let's say that this x here, this angle measure for this inscribed angle was 40 degrees. We could follow that angle out to the intercepted arc, and that arc would then be 40 times 2, which is 80 degrees. We can actually prove that with this equilateral triangle that is inscribed in this circle. Of course, an equilateral triangle has angles that are each 60 degrees. So we can assume we can assume that this arc and this arc and the third arc are also all equal because they are across from equal angles. Well, that encompasses the entire circle, all 360 degrees. Because 360 degrees is going to be equally divided by 3, that makes each arc 120 degrees. And so there is the angle times 2 equals arc rule in action. So those rules are pretty basic. Let's see how they might play out in some more complex situations. So here you see, a circle. We have a couple of diameters in there. We have a central angle of 19 degrees there at TUS. And we have PUR marked as a right angle, and we're asked to find all of these other arc measures. So my suggestion for a problem like this that's made up of all of these central angles is to find everything we can about the diagram, label it, and then we'll go in over here and answer these specific questions. So one thing we know is that since we have a 19-degree central angle, its arc is also 19 degrees. So I'm going to mark that as such. We also have vertical angles right here and right here. Vertical angles are congruent, so this angle QUR is also 19 degrees, as is arc QR out here. Well, we also have this right angle right here, and we have used up 19 degrees of it, which means we have 71 degrees remaining to get those 90 together, which means that 71 is also arc PQ. Now, a helpful hint for these problems. Diameters are our friends. So I'm going to highlight diameter TR here. And because these diameters produce linear pairs here in the middle, they are also going to produce semicircles. And so since we used up 90 degrees here with this right angle, it stands to reason that this is also a 90-degree angle and thus a 90-degree arc. We can also finally use really either diameter, but we'll use this one, to make another semicircle. Here we've used up 19 degrees of that. So that leaves 161 degrees for angle SUR as well as for arc SR. So now we have the entire diameter, or excuse me, the entire diagram labeled, and we can just answer these arc measure questions. So ST we see over here is 19 degrees. QR is also labeled 19 degrees. PQ is labeled 71 degrees, and SR is labeled 161 degrees. Now, the last one you see here is PSR. We use 3 letters to tell us to start at P, go around through S, and end at R. So we can add up 90 plus 19 plus 161 to get 270 degrees of arc for PSR. This next example here, we have some inscribed angles. You'll notice we don't have any central angles. V is the center point of this circle, and so we can tell that that line RU, for example, is not a diameter because it doesn't go through the center. We are asked at first to find arc RT, which is right here. Well, if we look around, we see that we have 64 and 139 and 75 and arc RT. And all of those things added up give us the entire circle, 360 degrees. So we could set up the equation 360 minus 64 minus 139 minus 75, and that would give us the leftover, which is angle X. As it turns out, that gives us 82 degrees. 82 degrees for arc RT. Now we're asked for angle RST. Angle RST starts at R, down to S as the vertex, and then up to T. So if I trace those two endpoints, I can see that the inscribed, or the intercepted arc for the inscribed angle RST is this 82 degrees. So coming back to the angle is the arc divided by 2, which is 41 degrees. 41 degrees for angle S. And now if we look at angle RUT, it's going to start at R, go down to U, and up to T, and there is its intercepted arc. Look, it's the same arc. So we're going to be doing 82 divided by 2 to get 41 again. So as it turns out, angle RST and angle RUT are congruent because they intercept the same arc up there. So that's a good example of how to do problems involving inscribed angles. Now our final example today actually includes both a central angle and an inscribed angle. So let's see how this is going to play out. Angle BED is marked as 8x plus 5. And angle BAD, the central angle, is marked as 12x plus 34. And we are to solve for x. So a couple of things are going on here. First, this central angle is marked as 12x plus 34. That means its arc is also going to be 12x plus 34. Now, if we go off of the inscribed angle, BED, that is 8x plus 35. So the intercepted arc, which is the same arc that we've already labeled, is going to be 2 times 8x plus 5, 2 times that inscribed angle, because angle times 2 equals arc. Well, we have these two expressions for the same arc based on these two rules. So we've effectively given that arc two different names, two different values. They're going to be equal to each other. Like this, both of them are going to be true statements. So we can use this as our sentence, as our equation, to solve for x. And so this means we have to distribute. It's going to be 16x plus 10. On this side, we still have the 12x plus 34. If we subtract 12x from both sides, we're going to get 34 equals 4x plus 10. Let me move up a little bit to get a little more space. We'll subtract 10 from both sides, and we are on our way to seeing that x is going to equal 6. So that's kind of the basics of central and inscribed angles. There are so many different types of problems and diagrams that, and they're really like puzzles. They're very exciting, but these will give you some basics with which to solve those puzzles. So I hope you will continue to check out these videos and learn from them and equip yourselves to do great in your math classes. You're doing great work. Keep it up and have a great day.